Hi, today we are going to talk about solving one and two-step equations. Um, in order to solve an equation, you need to do the inverse operation or the opposite operation. So you'll need to be able to recognize it. So addition and subtraction are opposites, multiplication and division are opposites, square and square root are opposites. Now this one we are not using right now. We will learn that later. So right now we're going to concentrate on addition, subtraction, and multiplication and division. This sign is a division sign. It is also a fraction bar, but it is the exact same thing. Okay, A divided by B. It's not just a fraction. It means that it's being divided. Okay, we need to be able to recognize addition. So whenever you see something being added together, we need to be able to recognize subtraction. So subtraction might look like x minus 5, but it could also look like negative 5 plus x, because this negative would be subtracting from that binomial. Recognizing multiplication. When something is side by side like this, like 3x or negative 6y or 19f, they are all multiplication. I can remind myself of that by putting my pen in between them, or my pencil. If I can put my pen or pencil in between them and not touch a positive or negative sign, then it is multiplying. We use a dot for multiplying now that we're freshmen and we're in Algebra 1, so this should be a regular thing. See right here, I can put my pen between these two and I hit a plus sign, addition. I can put my pen here and hit a negative sign or a minus sign, subtraction. Here, I don't hit that, okay? I hit a multiplication. Division looks like this as the fraction bar, division bar. So we're going to solve the following equations. First, we're going to draw our line. Then we're going to say, what's happening here? Well, I see a plus, so we must be adding, and the opposite or inverse operation is subtraction. So we're going to subtract, and we need to make sure that we have a balanced equation. So we need to do whatever we do on the left side, on the right side. So as you can see, 4 minus 4 is 0. It goes away because it's 0. It doesn't magically disappear. We're moving it on purpose, okay? It's like having a bank account. You have $100 in a bank account and a checking account. You want to move it to a savings account. You subtract the $100 from your savings and you put it in, subtract the $100 from your checking and you put it in your savings. So 7 minus 4 is 3. Now, how in the world could you know if this is correct? Well, you take your answer, right, and plug it back in. X plus 4 equals 7, 3 plus 4 equals 7, 7 equals 7. I got a true statement, so I did that correctly. The genius thing about math is that it can always be checked, so you don't have to think, I wonder if I did that right. Okay, right here, the operation that I see is multiplication. So its opposite operation is division. So I'm going to divide by 3. We always divide by whatever is in front of the variable that we are trying to isolate. So we need to have x by itself. So if x is hooked on to 3, multiplying by 3, we need to divide by 3. Okay, here's a scary one because it already is in a fraction. X is divided by 8 equals 2. X divided by 8, divided by 8. Oh, that's what I'm doing, divided by, right? And the opposite of division is multiplication. So I can multiply by 8 on both sides. Now this is like 8 over 1, which means that it goes away and x divided by 1 is just x. 2 times 8, 16. Now, if I wanted to check this, I could do x divided by 8 is 2. I could plug in what I got for x, and I could check it. No worries. Okay, now here's a two-step equation. These are all one step and only took one thing to do. This one is a little, these down here are a little different. So first, I have 6 and x, and I see that they're multiplying. And then I have this plus 5, so that's addition. And normally what I do when I'm going forward and not backwards, basically, when I'm not doing opposites, I do PEMDAS. But in this case, I have to do the opposite of PEMDAS almost. Okay, so addition and subtraction are usually at the last, and what I want to do is do it first, because I can't do anything with these guys right here until I move the 5 across. So 5 minus 5 is 0. I can bring the 6x down. I get a negative 3. Now 6 and x are multiplying. I can tell that because there's nothing in between them. They're all smushed together. And I did get x equals negative 3/6 or negative 1/2. Please do not tell me that this is negative 2. Okay, for it to be negative 2, it would have to be 6/3. The larger number would have to be on top. If you were going to put this into your calculator, you would put negative 3 divided by sign 6 and press enter, and you would get 0.5, which is 1/2. All right, you need to be very careful with your fractions. I do not want you to do this and then tell me x equals negative 2 and then get it wrong, okay? Okay, I'm gonna just switch pens since this kind of came over here. So I see this, I see these parentheses. So even though we're doing PEMDAS backwards in how we solve it, but with the inverse, we still have to do parentheses first, no matter what. So we're going to multiply in. We're going to get 2n plus 10, because 2 times n is 2n, and 2 times 5 is 10. Now it looks like something that I can do. I can't do anything with these two until I get the 10 to move away. So out of the neighborhood he moves. We get 2n equals negative 12. And then we want 2 and n to be apart, and so we divide by 2, and we get negative 6. You can see the difference here. Big number on top, small number on bottom gives us a whole number. Small number on top, big number on bottom gives us a fraction. All right? Okay, one last one. So I've got 2 plus m divided by 4. So I see that this 2 is positive, so I can move it over by subtracting it. Goes to 0. This goes to negative 4 equals m divided by 4. Now I just said m is divided by 4. So the opposite of division would be multiplication. So I'm going to multiply by 4 on both sides, and I'm going to negative 16 equals m. Now let's just say I'm like, ooh, I don't know. I don't know if that's right or not. Well, let's see. So we get negative 2 equals 2 plus negative 16 over 4. Negative 2 equals 2. Negative 16 divided by 4 is negative 4. Negative 2 equals negative 2. Check. So we made sure to check our work, because if we're not sure on something, there's no reason to be guessing. You can totally just check your work by plugging it in and seeing if it equals each other. Okay, y'all, have a great day.